an 800 meter cube area. Today's video is going to be in English. Proper PPE is very important always on ship. Before starting this video, it is important for me to tell you that my last cargo was Annex to caustic soda. This cargo is not flammable at all. It is a bit corrosive, but tank cleaning is already completed and there is no remains of cargo. It is absolutely safe. Make this video. Let's see the cargo tank, but before that, intro. It is important to see the ship's layout. So if you see the plan view, we have 1 to 6 wing and slop wing. One wing is a smaller tank, about 3200 cubics capacity. Rest all are about 4800. 6 wings is a bit smaller, 4300, and slop wings is about 600 cubics each. Side view, if you see forward, we have a 4-peak tank, bosun store, and then all these cargo tanks start 1, 2, 3, 4 like this, and aft is accommodation. Here is the engine room. This is a Framo ship. It is fitted with deep well pumps. Deep well pumps are fitted in each tank, and here is the pump, and which is driven by hydraulic power. This pump is a centrifugal pump, and depending upon hydraulic pressure, we can increase or reduce the rate of the pump. I don't know how much you can understand, but if you see this line, we have a main line going from wing tanks. Like one wing tanks have a common line going to the manifold, and this is the pump. This is, we have here main discharge line, and on this side you can see a smaller stripping line. We have a deck heater heating cargo, and then here what you see is a drop line. So for loading cargo we will use this drop line, and for discharging obviously we have to run the pump and use the discharge line. This ship is fitted with 4 power packs. Power packs are the units which provide power to these pumps. Basically what it means is that if you want to run more pumps, you are going to need more power packs, and this here is just a guideline for that. It will be impossible to cover all the data which these screens provide because they provide a lot of data. I'll just show you main things what it shows about the cargo tank. Here you can see we have radar gauges fitted on the tank, so it gives us ullage. Pressure sensor gives pressure. Temperature is at 2 level, lower and top. And cubics you can just ignore because this is not always accurate because ship is always trimmed or listed and things like that. Diagram which I have shown you, same thing can be seen here as well. These lines are all going to the manifold, and here we have our discharge line, drop line. This drop valve is a manual valve, so on this screen we just have an indication, but this one here is an hydraulic valve, and this valve can be opened or closed from this screen with a touch of a button. Similarly, on this other screen you can see the entire ballast water system and all the ballast related readings along with the ballast treatment plan. I am sailing on these type of ships from, just after cadet ship from third mate time, and I have sailed on a conventional pump room type, centrifugal, steam driven tanker, Marflex system and Framo system. So cargo operations was not that easy when we had this conventional ship, but today with this Framo system, deep well pump, everything is comparatively very easy and safe. This ship is fitted with inert gas generator. Of course, we are carrying Annex 2 cargo, chemical cargo, and tanks are not inerted, and this system is not being used. But in case we carry flammable petroleum product, then we will be using this inert gas. Purpose of this inert gas generator to create oxygen deficient atmosphere inside cargo tanks whenever we are carrying flammable product. This here is an independent system, and these are the alarms in case any problem with our radar gauges or we are not able to see correct readings or the correct level of fluid in the tank. Then we have these alarms fitted at 98% and 95%. So this will trigger an alarm and avoid overflow. Before entering into any cargo tank or during passage also, we are supposed to monitor the gas readings of all the tanks. So here you can see a portable meter. It is requirement to have minimum 2 of these on board, and here you can see a personal meter. It is requirement to have at least 3 of these. This can measure hydrocarbon level, H2S level, oxygen level in the tank, in inerted, non-inerted conditions. They're supposed to be carried with the personnel entering the tank, so that as soon as any hazardous atmosphere is encountered, equipment will trigger an alarm and that person can immediately evacuate or come out of that area. This equipment will measure H2S, carbon monoxide, LEL, that is hydrocarbon, and oxygen. Right now we have already completed our enclosed space permit, all the safety equipments like stretcher, resuscitator, breathing apparatus, EEBD, everything what is needed as per the checklist is already done, prepared at the site. Tank atmosphere is checked and everything is in order. That is, no hydrocarbon, no H2S, no other gases, oxygen is 20.9 and we can safely enter the cargo tank. This here is a manifold area. Of course we have manifold area on the port side as well as on the other side, that is starboard side. All the cargo lines from cargo tank end here at the manifold. In case of loading also we will connect a connection here. In case of discharging also we will connect a connection here, the shore. Only difference between loading and discharging will be that during loading shore will be using their pumps and during discharging we will be using our pumps. These valves here are on all the lines and connected to each other. This is called manifold crossover. Imagine we have some kind of cargo in 2, 3, 4 and my shore connection is only on the 4. So what I want to do is open these crossovers so that I can discharge from my 2-wing, 3-wing tanks as well using the number 4 line. This valve and this valve here is called line master. Purpose of these line masters is that suppose I am not running that tank, I am discharging some other tank using some crossover, so I need to have double valve segregation to avoid contamination. In that case I will keep it shut, and of course when that line is in use you have to keep it open to have your cargo come all the way up to the manifold. No points for guessing what this is. This is a tank dome. This is the entry into the cargo tank. This being a tanker, you're not going to have big hatch openings like you see on a bulk carrier. They have given this extra opening. It is to be used for rescue, lift somebody on a stretcher, and as you can see there's no ladder under it. This is the pump. This is the aft side of the tank. We'll see it later. But next to this aft side, what you can see is opening. This is called ullage pocket. You can fix to your ullage measuring device. This ullage pocket is fitted with a UTI. UTI is capable of giving you ullage and temperature. All you have to do is open this valve, lower the tape onto the level of the fluid, and you get the ullage. As I showed you in CCR that these tanks are fitted with radar gauges, and radar gauges send microwave onto the level of the tank, returns and measures the ullage. They are pretty accurate, but for critical operations like topping off or when it is stripping, when the tanks are empty, we use manual gauging using a UTI that is fitted on these ullage pockets. Some ships have ullage pocket aft and forward, some ships have aft, center and forward. Okay, now this is going to take some time to explain you all. This is a hydraulic inlet and return line. So this hydraulic flow, hydraulic pressure drives the pump, and here we can manually control what pressure and how fast or at what capacity we want to run the pump. So as you turn it clockwise, the pressure will increase and pump discharge rate will increase. But we never use local control. The control is normally in the CCR. Only during stripping time, guy stripping the tank can manage the pump pressure locally as per his needs. Temperature sensor goes all along the pump discharge line inside the tank, providing us lower and upper temperature readings. We are left with 2 more lines. This line is a stripping line. As you can see, the main line is so big, so when the tank level is low and when we don't have that much cargo, we pressurize this line using pneumatic, that is air, and get the cargo out from this smaller line. This other line is leading to coffer dams. We ensure that there are no leakages and all the seals are intact. To do that, after every operation and during the passage, we have to purge these pumps, and purging is done using these lines. This here is a hydraulic discharge valve, can be operated from CCR. During bulk discharging, this valve will be full open. As the tank level goes down, we keep throttling this valve so that my pump never loses suction. Right over there, you can see this line. Right over there, again going into the tank, and that is a drop line. Drop valve is manual. If you closely see, we have another line here and a valve here going into the heater. For heating cargo, it also has steam connections to provide heat to the heater, and then again it is going over there and going into the drop line. So basically, as the line suggests, this is a recirculation line. During passage, if we want to heat our cargo, all we do is run this pump, ensure that valve is shut, this lineup is all open, and pass the cargo through it. So it will keep recirculating and keep passing through the heater, providing heat and raising temperature of the cargo. Drain lines, so purpose of these smaller lines fitted everywhere onto the main line is to drain the line after the operation so that nothing is frozen and the entire line is free of cargo. From another angle, main drop line and recirculation drop line, all connecting to the same place going inside the tank. Let's quickly see what do we have on the heater. So heater has a cargo inlet, cargo outlet, steam inlet and smaller line steam outlet, and of course there's a provision of blanking it. And as I said, all the main lines will always have drains, so we have drain for steam line as well as drains for the cargo line. I said something about making oxygen deficient atmosphere inside the tank, so here is the inert gas line. This line is providing inert gas into the tanks, this one to the port side, that one to the starboard side. There is a requirement to keep these IG branch valves locked, and key is always only with the chief officer, and only chief officer is authorized to open or shut these valves. When we have a provision to fill inert gas in the tanks, we have a provision to vent it also. So venting is done using the PV valves. PV means pressure and vacuum valves. They will act when the pressure inside the tank is too much. Pressure side will release the atmosphere. When we have a vacuum in the tank, vacuum side will allow air to be sucked inside the tank. This pressure valve is designed to operate on its own when the pressure is high, but sometimes we have to manually release the pressure, and to do that you have to use this handle and lift it up like this. During tank cleaning purpose and during gas spring and etc., we don't want this pressure system to be operational and we want free flowing ventilation from the tank. That time we will use these purge flaps. You have to just open it, and there's just a normal opening which will bypass this vacuum side as well as the pressure side. We have already seen the aft side ullage pocket. This is the center ullage pocket. Next to that is high level and overfill alarms. This one here is a radar gauge providing ullage. This is a programmable fixed tank cleaning machine, and this is the valve for that. You open this valve and we have water or hot water, whatever you want, coming from the main line and going into this machine, and this machine rotates. It can go from 0 degrees, that is down, to up, and it can rotate at an angle and all these settings we can change here if we want the machine to run fast or slow. And on top we can monitor if this is rotating, means the machine is working. All tanks are fitted with a fixed tank cleaning machine, but in case that one fixed tank cleaning machine is not enough and it has some blind sectors in the tank, then we use these portable. We have 2 of these, and from the butterworth pocket these can be lowered in the tank, provide additional cleaning machines. Main tank cleaning lines runs from aft to forward, and we have different ways to put water in the tank cleaning machine. One of the ways is to have water in starboard slop and give the drive from aft starboard slop tank. Second way is to have seawater from here. If we want to wash it with seawater, this line is coming from ballast pump. Ballast pump will be running at low RPM, just enough to have the water here, and then this tank cleaning pump, yellow color, will boost it and provide us 9-10 kg pressure in the tank cleaning line. In case we want to have hot water, then this salt water will be passed through this heater. Heater has steam inlet, steam outlet, of course seawater inlet and seawater outlet. I think I have shown you everything outside and all the fittings of a cargo tank. Now it's time to see the same things from inside the tank. Be very careful guys, whenever you're going down these ladders. You cannot afford to fall. You have to ensure 3-point contact always. I am somewhere in the middle. I will show you all the fittings which I showed you from outside. That one here is an emergency opening where it was written no ladder. Next to that is a butterworth opening used for lowering portable tank cleaning machine. Longer one with a nozzle is a fixed tank cleaning machine. Next to that is a higher level and overfill alarm. And then you have a main discharge line which has concentric hydraulic lines as well. And down you have the pump. Next to that is a drop line used for loading, and cargo cannot be just falling from the top. It has to smoothly go down, so that slanted line does that job. started the pump and we are gonna do the stripping of this remaining quantity of water. We have already completed tank cleaning of this tank, but there were still some patches remaining, so we are doing local cleaning here by using a fire hose which has been lowered all the way inside the tank. This is huge, 4,800 meter cube area. Corrugated bulkhead on aft side, plain bulkhead but other side has a ballast tank. This is a partition with the other cargo tank, again corrugated bulkhead. Forward also is a partition with another tank, corrugated bulkhead.
ISO. Indies. Yeah. Live free, speak your piece.
Like it for hard work of my crew and seafarers. Subscribe if you haven't already done. Smash that button, press the bell icon, do whatever you like. Stay fit. Jai Hind. I will hope to see you on the next one. Time for well-deserved lunch. Sunday lunch, Indian ship, biryani.
In these streets. Let's go. Playground parks with the trees and the cars. Brownstone buildings with the kids on the porch. Murals on the walls for the ones that we lost. Bodegas on the corner, let me see what's in store. Subway stations with the maps in the